Alright, hello. In this video I'm going to be working Algebra 2 Quiz 2.3, which is about systems of linear inequalities. And so we're going to start just graphing a solution region. Okay, so y is less than or equal to 2x minus 10. Oh, that's a little tricky. Less than or equal to 2x minus 10. Okay. So that would have a y-intercept of negative 10. That was another reason why I didn't like this quiz. This was like kind of unfair. Let's see, what happened on form B? Y equals negative 2x plus 16. Yeah, sure enough, that one would have actually fit on the thing. Yeah, this was just not a good quiz, but it's okay. It's going to have an x-intercept of 5, 3, 4, 5, and it's going to have a slope of 2. So it's going to go through these points, and I'm just going to use a ruler. Okay, since it's less than or equal to, it's going to be a solid line, and I know it's going to have a slope of 2, and it looks like that's going to maintain that slope. Okay, I hope that was good. Okay, and then we were going to say, all right, x plus y is less than 14. Well, that's going to be y equals 14 minus x, which I know kind of starts up here at 14 and goes down to 14. We've graphed a number of these. 2, 4, 6, 8, 10, 12, 14, 2, 4, 5, 6, 8. No, I've lost myself. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so we're going to connect these 2 points. And it's going to be a dotted line because it was a strict inequality, I remember. Okay, so. Okay, now if it's where y is less than or equal to the solid line, okay, that's going to be down here along the negative y-axis, which we can't really see, but it's going to be underneath this line. But it's also, this is going to be y is less than negative x plus 14, so it's going to be underneath this line as well. So the solution region is going to be right here, that triangular area. But it's going to keep going beyond the x-axis, just beyond where we are plotting. Okay, now the system of linear inequalities, y is greater than or equal to negative 3/7 x plus 5, and y is greater than 2x minus 1. Okay, which quadrants have solutions? What I'm going to do to make it easiest to see is I'm going to say, all right, positive slope, negative y-intercept, the positive slope is pretty steep. Okay. And the y-coordinate of the y-intercept is pretty close to 0, so I'm going to just draw it like that. And I know it's supposed to be dotted, but you know, you could do one of these, you know, like it's supposed to be dashed. Okay, but we're really just thinking about where the solutions are. Y is greater than, it's going to be above that. But then y is also greater than or equal to negative 3/7 x plus 5. So maybe 5 is right here. Negative 3/7 is, I mean, it's less than 1. It's going to have a negative slope, and it's going to be kind of shallow. So I'm going to say, all right, it's going to be kind of like that. And we're above that one as well. So our solution region is above this one and above that one. So it's this part up here. And I'm going to say that the solution region sits in quadrants 1 and 2. Okay. All right. Now, for number 3, we're going to find the area of the solution region. Okay, y is greater than or equal to 1, and y is less than or equal to x plus 1. So I think 1 is going to be an important spot. Okay, y is greater than or equal to 1, it's going to look like this. And y is less than or equal to x plus 1 is going to, I mean, this is going to kind of go up like that. So, but it's going to be underneath this line and above that line, so it's probably going to be a triangle. X plus y is less than or equal to 5. Well, I'm going to draw 5 here, try to give it a slope about -1, but it's not going to be the most important thing ever. Because we're not like counting squares or anything, we're going to actually do some measurements here. Okay, we're going to need the coordinates of this intersection. Okay, now to get the coordinates of that intersection, we're going to need to say, where does y equals x plus 1 run into y equals negative x plus 5. Okay, so I might do some substitution, right? Y equals x plus 1, y equals negative x plus 5, substitute on the y's, and that's going to be where x plus 1 equals negative x plus 5. So I might subtract 1 from both sides, add x to both sides, and then realize, okay, x is going to equal 2. Okay, and then what I really need from this is the y coordinate, though, to get the height of the triangle. So, but y is x plus 1, and also negative x plus 5, so y needs to equal 3. Okay, so that's at a y coordinate of 3. Now I'm going to need the x coordinate of this point in order to figure out the width of the triangle. So to do that, I'm going to go and I'm going to run these two lines into each other. So this is y equals negative x plus 5, and this is y equals 1. So I'm going to do substitution again, and I'm going to say 1 equals negative x plus 5. I'm going to subtract a 5 from both sides, and I'm going to say, all right, negative 4 equals negative x, so x needs to equal 4. Okay. So now I know that the width of my triangle is 4 and the height is 3 minus 1 is 2. So the area of this triangle is going to be 1/2 times the length of the base, which was 4, times the height, which is 3, so that would be half of 12 is going to be 6. Now we're going to look at this system, or look at this region and write a system of inequalities. And there wasn't even one that was dotted. That's a shame. Okay. Again, could have done better on this quiz, but it's okay. All right. Over here, this is a horizontal line. This is the line y equals 1, and we're above it. So I'm going to start with y is greater than or equal to negative 1. Okay. I need an equation for this one. This looks like it went down 3 when it went over 1, so it's going to be negative 3x plus 2. And this is where we're above this line. Okay, so this is going to be where y is greater than or equal to because it's a solid line. And then this other one with a negative slope, it looks like it's got a slope of going down 1 when it goes over 2, so that's a slope of negative half. Y-intercept is 2. But we're below this line, so that's where y is going to be less than or equal to this. Okay, and since I've got 3 lines, I should have 3 inequalities, right? Okay. Then over here, George has been hired by a local clothing accessory store to make decorative belts that have green and blue beads carefully glued on them. Okay, yeah. Each bead is 1 centimeter wide, and each belt has to be between 70 and 80 centimeters in length. So if green is x and, y is green and x is blue, we're going to write a system of inequalities. Well, the length is going to be between 70 and 80. So the total number of beads needs to be between 70 and 80 because each bead is 1 centimeter. So x plus y needs to be between 70 and 80. Okay. And then the ratio of green to blue, green over blue equals, it's between 1.5 and 1.8. Okay, that's a system, it's going to be an inequality. If you don't like the look of this, because it's like, we haven't talked about y divided by x, okay, that's why I let y'all work together on this. But also you can multiply all 3 sides of this inequality by x and say 5x is less than or equal to y, which is less than or equal to 1.8x. If you think about what it means for the ratio of green to blue to be between 1.5 and 1.8, then green is going to need to be between 1.5x and 1.8x. Same idea. And this is pretty much all of the restrictions that I'm working in. Yeah. Okay. Now, x plus y equals 70 and x plus y equals 80. These are 2 of these lines that have slope -1 and they have, the same x and y intercept. So, x plus y equals 70, maybe that's here. Now I'm going to draw kind of an exaggerated picture because that will help me with the question 7 when I'm, actually using my sketch. Okay, that's going to be x plus y equals 70. Then I'm going to draw x plus y equals 80, but I'm going to let this go out a ways, maybe really towards the edge of the field. So it's not going to be drawn to scale, but that's fine. And then y equals 1.5x. Well, we know that that's a line that goes through the origin. It has y-intercept 0. But 1.5x is definitely less of a slope than 1.8x, so I'm going to draw that in a really exaggerated way. So I'm going to draw one pretty shallow and one pretty steep. And because this is only a sketch, it won't really matter. And it will give me a much better looking solution region. And then this is going to be 1.8x over here. Even though I know that this is not, it's the actual region itself is much smaller to look at if we were to draw it to scale. I'm just kind of drawing it at an exaggerated scale so that we can have more region to look at. So, since it's between these two lines and between these two lines, it stands to reason that my solution region is this thing in here. And that'll be a really nice sketch. Okay. Now we're going to talk about the cost thing, bring in the objective function. So 10 cents per green bead and 12 cents per blue bead. But we want to minimize the cost of supplies while staying inside these restrictions. So the best response to this that I heard was somebody in the crowd in my class was like, okay, I was saying you need to check the corner points. Those are always like the maximum and minimum spots. And I was just kind of going through and making a list and not thinking about it too hard and just, running all of those through, finding the intersections, doing all that stuff. And then somebody threw up their hand and was like, yeah, I don't think that's necessary because if you're trying to minimize the cost of supplies, you're going to use the minimum number of beads, and that's going to be 70, right? And moreover, if you're trying to save money, you're going to use as many green beads as possible. So you want y to be as high as possible and x to be as low as possible along, x plus y equaling 70. So they were suggesting that I should use this point right here, and that's exactly what you should do. Okay, so that's the point I'm interested in to minimize my cost of supplies. So in order to find out the coordinates at that point, I'm going to have to run these two lines into each other, and that's solving a system. So I've got x plus y equals 70 here, and I've got y equaling 1.8x, not 1.8. Pardon me, y equals 1.8 would be a horizontal line. Okay, so y equals 1.8x. And then I'm going to, use substitution. Okay, 2.8x equals 70. If I divide 70 by 2.8, I'm going to get 25. And, hold on. Yeah. Then I would let you think about that, bring out a calculator and verify my arithmetic, but that is what it's going to be. X is going to be 25, and y is going to be 1.8 times x. 1.8 times 25, 1 and 4/5. I know that 4/5 of 25 is going to be 20, so this is going to be 45. Oh man, that was a way easier for me to find that. Especially, I don't know, if you're like multiplying by 1.8, not my strong suit. X plus y equals 70, that would have been much easier on an arithmetic level to make sure these added up to 70. Okay, but that's going to be the combination of blue and green minus cost. Okay, that's Form A. Let's move on to Form B. All right, we're going to start by sketching a solution region for the system of inequalities. So this is going to be y is less than or equal to negative 2x plus 16. Okay. 2, 4, 6, 8, 10, 12, 14, 16. And I'm going to think about where this is going to equal 0, and that's going to be at y equals 8. I mean, at x equals 8, pardon me. And so I'm going to give myself a little bit more to aim at rather than 2 points that are right next to each other. And, all right, since this is y is less than or equal to, I know I need a solid line here. And y is greater than x plus 1. Okay, there's 1. Here's going to be positive 1x. Let's see, it's going to run in at this spot right here, so I might as well just kind of aim for that anyway. And this is a strictly greater than, so I'm going to draw a dotted line. All right, so y is above the dotted line and below the solid line. That's going to be this region off to the left here. And it's going to keep going beyond the y-axis, right? That's all I've got to draw on, so I'm just going to draw it like that. All right, 1/3 of x minus 2. Well, that's got a pretty low slope. That's like, so it's going to be pretty shallow. It's got a negative y-intercept. So I might draw it, about like that. Whoops, that might have been a little too exaggerated, but it's all right. I think it's not going to be that hard to tell. Yeah, 3x minus 4, so that's a lower y-intercept and a steep slope. Okay, and if y is greater than the solid line, okay, the 3x minus 4 is supposed to be dotted. Okay, pardon me, I did this when I was working Form A also. Okay, y is supposed to be above the solid line and below the dotted line. That's going to be these two. And now, if you were unsure about your sketch, I'm pretty sure about my sketch that if anything, that I kind of underestimated how steep y equals 3x is and the difference in scale. So I'm reasonably certain that this has to intersect down here in the fourth quadrant, meaning that there has to be solution points in the fourth quadrant. If you're unsure about that, then you're going to use substitution or elimination to compute the x and y coordinates of this point, just to know for sure. But I'm feeling confident. I believe that, or I know that there are going to be solution points in quadrant 1 and quadrant 4. Okay, now we're going to find the area of the solution region to this. All right. All right, I know what this is going to look like. All right, negative 4x, plus, so y equals 1 is going to be right here, and I'm going to draw that in. All right, 4x plus 9, that's going to be pretty steep. That's going to come down like, that would be like this, right? If this is 9. And then negative 4x plus 9 is going to come down like this with the same slope, but negative. All right, I tried to draw that as good as I could, but it's very, very rough. Okay, one, it's supposed to be symmetric across the y-axis. I didn't draw it that way. But what we know is that the height of this triangle is 8, because it goes from 1 up to 9. It's the width that we're interested in. So I might find the x-coordinates of these two intersections. Okay. And this is where 4x plus 9 is equal to 1 right there. All right, just set the y's equal to each other. That's 4x equals negative 8 when I subtract 9, and then I get x equals negative 2. Okay. If you can tell that this is supposed to be symmetric, you know that that's supposed to come back 2, but it might be good that we convince ourselves of that since I drew it so poorly. Negative 4x plus 9 needs to equal 1. I'm going to subtract 9 from both sides, and I get negative 4x equals negative 8. Divide by negative 4, and I get x is positive 2. So now I know this has a width of 4 and a height of 8. Really, really not drawn to scale. Okay, but I know how to find the area of this. It's 1/2 times the length of the base, which I've determined is 4, times the height, which is 8. So 32 divided by 2, that's going to be 16. Okay. Now, over here, we're going to write a system of linear inequalities that matches the graph. Okay, these are all solid lines. A vertical line has an equation like x equals something. So this is the line x equals 3, and we're to the left of it, so I know that x needs to be less than or potentially equal to 3. This looks like y equals x plus 2. So you can do that, right? Write the equation of the line, say, okay, it's a solid line, so it needs to be something or equal to, but it's below that line, so it's where y is less than or equal to. And then this last line with negative slope here, I see a slope of over 3 down 1, so negative 1/3 x, y-intercept is 2, and I'm above this line, so that'll be where y is greater than or equal to because it's a solid line. over here. Now we've got George and the decorative belt again, and I think on form B, you had some problems on the front side were a little nicer, and then this one was a little worse because of the, oh no, Y is still green beads and X is still blue beads. So I still don't understand how this is supposed to be different on form B. Maybe it's not supposed to be, maybe it's supposed to be the same. And if you already saw me work this, I'm pulling out form A, and we're gonna just compare it exactly. 70 to 80. Ratio of green to blue must be at least 1.5 and at most 1.8. Y represents green beads, X represents blue beads. 10 cents and 12 cents. Yeah, it's going to be the exact same. So if you're just watching and you did not see me work this on form A, I'm going to just walk you through my solution. Okay, if X is the number of green beads and Y is the number of blue beads, and each bead is 1 centimeter long, then the total length has to be between 70 and 80, right? So the total number of beads is the same as the total length in centimeters. It's got to be between 70 and 80. And if the ratio of Y to X is between 1.5 to 1.8, the ratio of Y to X is Y divided by X. And so Y divided by X is between 1.5 and 1.8. And we can get this into something we graph as a line by multiplying all three sides of this inequality by X. Okay. And then we would have, 1.5x is less than or equal to Y is less than or equal to 1.8x. If we wanted to graph this, we could think of this like this one or this one as two different inequalities. X plus Y less than or equal to 80. That's Y is less than or equal to negative X plus 80. Okay, we could go over here and just kind of like ignore that one and just one at a time. X plus Y is greater than or equal to 70. So Y is greater than or equal to 70 minus X, or negative X plus 70, however you want to say it. And so we can do the same with these. We end up with this solution region. Okay, we graph Y equals 1.5x, Y equals 1.8x, X plus Y equals 70, X plus Y equals 80. Okay, it's the region in between all of those. And then, if we're considering the cost and we want to minimize cost, well, we want a maximum number of green beads and the minimum number of total beads, which is going to be this corner point right here. We're going to solve for those coordinates with substitution, and then we would get the actual combination of green and blue beads that he should use. Okay, that's going to be all for this video. I hope it helps, because I was not much help while y'all were taking this quiz. I kind of just told y'all to figure it out, telling you that the solutions would come eventually. Here they are. Hope they helped. Thanks for watching.